Hey guys, how you going? This is Eddie the Magic Monk. One of my subscribers requested a video on inequalities, so that's what we're going to work on today. So the first thing I want to do is talk about what is an inequality. So if you remember with equations, we usually have a variable is equal to something, is equal to a number. Now, if I represent this equation on a number line, okay, so a horizontal number line where we have just some numbers on it. Let's put 0 there somewhere. 1, 2, 3, 4, 5. Sorry about the scale. So x equals 5 will just be a dot on that number line where 5 is, correct? Okay, now if I want to draw a number line for something like this, x is smaller than 5, okay, then what you would do on your number line is where 5 is on that line, you're gonna draw a dot, and sorry, let's make this smaller and smaller or equal to 5, and you're gonna draw an arrow backwards this way, okay, indicating that we are continuing forever. Now if you have x is smaller than 5, what you can do is on your number line you can draw, I'm just gonna do a quick version this time, a hollow dot and an arrow pointing this way. So that means that x does not include the number 5 itself, but it includes everything to the left of it. Okay, so that's how you represent an inequality on an inequality on the number line. Okay, now let's try to represent this on a Cartesian plane. Okay, so if you want to draw a graph of x equals 5, okay, you would have a Cartesian plane where you have x-axis, y-axis, and x is equal to 5. So x, you would go to 1, 2, 3, 4, 5. So you would draw a vertical line down because anywhere along this line we have an x coordinate of 5. So this line here is x equals 5. Okay, but what if we want to draw x is larger than 5? Okay, so I change this now to x is larger than 5. Okay, what you would do is you would highlight the entire area to the right hand side of x is equal to 5. You would highlight this area. Now the reason why you would highlight that area is because anywhere to the right hand side of this line has an x coordinate, larger than 5. Okay, all the highlighted areas. So that's how you graph an inequality. Okay, so let's do something a bit more complicated. So let's have two variables. So let's do, for example, y equals x plus 3. Okay, so obviously you would have a Cartesian plane. So I just quickly copy this graph from Google. I assume that would be allowed. And then you can see here y equals x plus 3 is this line here. Okay, so what if we want to draw a graph of y is bigger than x plus 3. Okay, so let's have a look at this line here. Now, if we have y equals x plus 3 somewhere on this line, so let's say this dot, when x is 0, y equals 3. If y has to be bigger than that value, so y coordinate has to be bigger than 3, then it would be everything higher than that. Okay, so in other words, we're gonna highlight above every single dot on this line. So we're gonna have to highlight this whole area. Anywhere above the line, we have to highlight it. Okay, so that, and we don't highlight this little bit here on the line. Okay, so that would be the graph of y is bigger than x plus 3. So don't highlight this little bit. Okay, so that's how you graph inequalities. And the last thing I want to talk about is how to solve one. Okay, so solving inequalities. Now, inequalities are pretty easy to solve because most of the time you just treat it like an equal sign. So, for example, if you have 3x plus 1 is bigger than 8. Okay, you can pretty much just pretend that the inequality is the same as equals. So you can just do 3x is bigger than 8 minus 1 is 7, and x is bigger than 7 over 3. Okay, so you have solved it. X has to be bigger than 7 over 3. Now, if you don't believe me, you can try to substitute this number into x and you can test it out. So do a quick test. So if x is equal to, and just think of a number smaller than 7 over 3 or smaller. So let's try 6 over 3 for example. Okay, because that's smaller than 7 over 3. If you put it in that equation, 3 times 6 over 3 plus 1, okay, that becomes 3 and the 3 cancel each other out. That becomes 6 plus 1, which is 7. 7 is not, which is not bigger than 8. Okay, but if you try a number bigger than 7 over 3, so let's try 8 over 3. So that becomes 8 plus 1, which is 9, which is bigger than 8. So therefore 7 over 3 looks like a pretty good answer to me. Okay, now the only time where you have to take care of solving linear inequalities is when you have a negative number involved somewhere. Okay, so let's try this. Negative 5x. So solve negative 5x plus 7 equals 10. Okay, sorry, not equals, is larger than, is larger than 10. Okay, now you would do the same thing as previously when you are solving it. Treat it like an equal sign. So I'm going to move the 7 to the other side, so it's 10 minus 7, which is 3. Now this is where it becomes difficult. When you multiply or divide by a negative number which is what we're about to do, reverse the inequality. Okay, now I'll just explain with another example why we do that. Okay, so for example, if you have 5 is bigger than 3. Okay, if you multiply both sides by -1, so 5 times -1 and 3 times -1, what happens is you end up with -3 and -5, and which one is bigger? Okay, if you try to maintain this sign, -5 is no longer is not bigger than -3, so therefore you have to reverse the sign when you multiply both sides by a negative number. So that's what we're going to do. Okay, so we're dividing both sides by -5, so I'm going to do it to both sides so you can see what we're doing. So when we divide by a negative number, we reverse the inequality. So now we have x is smaller than -5/3. Oh, sorry, -3/5, because the negative sign doesn't matter whether you put it at the top or at the bottom, you will end up with a negative number anyway. Okay, I hope this tutorial has helped you a little bit with inequalities. We're going to do a bit more later on with perhaps solving quadratic inequalities. See you guys next time.